All right, so before we take a look at number 11, just be aware that the way that you solve this problem may not be covered by your professor. And so your professor may tell you to go ahead and skip number 11 and not worry about it because you won't be given anything like it on your test. But your professor may cover it in class, and therefore you'll be responsible for knowing how to do this type of problem for your test. So just be aware. Either way, I'm going to show you how to solve this problem, so you're covered either way. But just take a note that your professor may tell you to skip number 11 on the practice test, and so you can go ahead and skip this video and move right to number 12. But even if your professor does tell you to skip number 11, it may not be a bad thing just to sit here for a few minutes and take a look to see how you would solve one of these. All right, so let's go ahead and dive in. And we're told to solve the problem and that the perimeter of a rectangle is 40 meters. If the width were doubled and the length were increased by 14 meters, the perimeter would be 82 meters. What are the length and width of the rectangle? And I should point out that excuse me, when they are asking us what are the length and width of the rectangle, they want us to tell them what the original length of the rectangle was and what the original width was. They don't want to know what the new width and length are once we've doubled and increased by 14. All right, so what are the length and width of the original? So maybe I'll just squeeze that word in here. All right, so let's go ahead and take a look, and I'm going to draw just a diagram just to kind of help us to see what's going on. And we all know what a rectangle looks like, right? And they're telling us that the perimeter of this rectangle is 40 meters. And they don't tell us what the length and width are, and so let's go ahead and just represent the length and width by some variables. So L for length, W for width. And we know that the perimeter of a rectangle is just the sum of all four sides, right? And so if we wanted to get the perimeter of this rectangle, we would say that length plus the width plus the width is equal to 40. And we can combine our like terms here, can't we? So this would be 2L plus 2W equals 40. And that's how we could solve for the perimeter, assuming that it was 40, using this equation here. Excuse me. But they don't want us necessarily to use this information because they give us some additional information that they want us to use in conjunction with this equation. So now they're telling us that the length has increased by 14 meters and the width has been doubled. So let's take that information and adjust this standard equation by the new information they've given us. So they're telling us that the length has increased by 14 meters. So now we're saying the length has increased by 14 meters, right? Plus 2, and the width has been doubled. Well, how do you write 2 times the width? Well, that's how we would double the width, right? Whatever the standard width was, we're now doubling. Equals, and what's the new perimeter if these two scenarios were to take place? If we increase the length and double the width, well, the new perimeter would be 82. All right, well, let's go ahead and work this out. Let's clean up the left side here. So we're going to distribute this 2 through, and then distribute this 2 through. And we have 2 times L, well, that gives us 2L. And 2 times 14, well, that gives us 28. And then plus, and now distributing this 2, we have 4W equals 82. And let's go ahead and move this constant over. So we'll subtract 28 from both sides, leaving us with 2L plus 4W. And that's going to equal, let's see, 54, I believe. All right, so now we have another equation, don't we? A new equation with this doubling of the width and the length being increased by 14 meters built in. So here was our original equation without any adjustment to the length and width. And here is the second equation with that adjustment to the length and width. So now we have what? 1 equation, 2 equations. Well, that looks like a system of equations to me, doesn't it? So let's go ahead and take this information, is 2L plus 2W equals 40, along with the 2L plus 4W equals 54. And let's set this up into a system of equations and solve. How about we do this one by elimination, because it's set up relatively nicely. And so again, let's go ahead and eliminate our L, our length. And I have a positive 2L here and a positive 2L here. So I'm going to go ahead and negate the first equation here by multiplying the whole thing by -1, right? Because if we have a positive 2L, then in order for the L to cancel, we need a negative 2L. And I'm going to write the result of that negation right below. So -1 times 2L, well, that gives us negative 2L. -1 times positive 2W gives us negative 2W. And -1 times 40 gives us negative 40. And let's go ahead and add these two equations together. So 2L minus 2L goes away. 4L minus 2L, 4W minus 2W gives us positive 2W. And 54 minus 40, well, that's going to give us a 14. And solving for W, we'll divide by 2, and so the width is 7. And now that we've solved for our width, we can go ahead and take this value and plug it back into any of our equations here. And how about we plug it into, let's plug it into just this standard first equation here. All right, so we're going to have 2L plus 2, taking out the W, putting in our new value that we just solved for, of 7, all right, equals 40. So we have 2L plus, well, 2 times 7 is 14, equals 40. We're going to subtract 14 from both sides, leaving us with 2L equals now 26. And divide by 2, and so L equals, well, 26 divided by 2 is 13. All right, and so there we have it. We solved for the original width and length of this rectangle. And if we went ahead and tested to see whether or not this is true, let's find out. So again, we're saying that the length is 7. Let me go ahead and do it this way. So the length is 13, excuse me. 13 meters, and the width is 7 meters. And let's see if that's true. Well, length is 13, so 13 plus 13 is 26, plus 7, so 26 plus 14 does indeed equal 40, and so we know that our measurements are correct. All right, so that could be a tricky one, especially if you're not trying to use a system of equations to solve, right? Once we had our two equations, this became just something that we were really familiar with, but actually deriving these two equations could be a little tricky. So again, your professor may not cover this type of problem in your class, and if so, go ahead and just skip this one on your practice test. You won't be responsible for anything like it on the actual test, but your professor may indeed want you to know how to solve something like this, so just be aware. All right, let's go ahead and take a look at question number 12 in the next video. See you there.